All right, folks. So the topic of the day here is covalent bonding, naming covalent compounds. That's what we're going to be working on. Um, this is a screencast for the 2014-2015 school year, so I'll be referencing certain pages in the packet. Those pages may change depending on um, what what we got in the packet for that year. So just keep that in mind. But I will tell you the names of stuff. So what I'd like you to have out now is somewhere for you to take notes. That might be a blank page in your packet. I know page 4 and 5 in this year's packet are nice notes pages. You want to have your periodic table out, and specifically the one that has the polyatomic ions on the back, and there's something called prefixes on there. Those are going to be important for us today. So you want to have that out. And what I'll kind of be walking through here is actually the notes that are on page 2 of our current bonding packet. So you can follow along with those, or you can jot stuff down on those blank pages of 4 and 5. All right, so if we're talking about bonding here, and specifically we're talking about covalent bonding. So what is a covalent compound? If we look at these covalent molecules that we have as examples, we have oxygen there, we have phosphorus bonded to fluorine, we have carbon bonded to oxygen, carbon bonded to hydrogen, and then hydrogen gas at the end. Take a minute and see if you could think about what these all have in common. Where are they on the periodic table? And you could pause the video to do that. So you can see that they're all to the right of that staircase. And hopefully we remember that everything to the right of the staircase on the periodic table is what's called a nonmetal. Okay, unless it's on that staircase, then it becomes a metalloid, but that's a whole story altogether. Anyway, everything we see here in our examples are nonmetals. So we have nonmetals bonded to nonmetal. That's what a covalent compound is. Nonmetal bonds to nonmetal. So we have no metals here. That's important. Okay? This is different than ionic. If we've talked about ionic already, ionic compounds are a metal and a nonmetal, a cation and an anion. The only exception here would be ammonium. Remember, NH4 is a cation, so even though there'll be ammonium compounds that have no metal in them, they are considered ionic. Okay, covalent, what does that mean? Well, the prefix co means together, and then valent refers to the outer valence electrons. So these atoms that form covalent compounds are actually sharing their valence electrons so that they can have 8, so that they can be stable compounds. Okay. One thing you want to consider is that when you look to the right of that staircase and you see all those nonmetals, remember if they form ions, they're always negative. They're always anions. So you're not going to see any ionic compounds forming there because negatives don't combine with negatives if you're talking about ions. So instead of forming ions, they actually share their electrons. They're not all taking electrons, they're sharing them. It's a covalent compound. Okay, so here's really the meat of this lesson. How do I name a covalent compound? We have 3 rules to do this. The rules. Rule number 1, write the full name of the first atom. Rule number 2, write the name of the second element, but change the ending to IDE. So we're coming back to these IDE endings. If you remember with ionic, the nonmetal, if it was just an atom, if it wasn't a polyatomic, it ended in IDE. So the question now will become, well, if I have an IDE ending, how do I know if it's ionic or covalent? Hopefully you can answer that question, because we now know that covalent compounds don't have any metals. So if there's 2 nonmetals bonding, then it has to be covalent. Okay. And the third rule, and this one's in bold for a reason because it's how we identify covalent compounds versus ionic compounds when they're written out, the name of the compound, and that is we use Greek prefixes to identify subscripts. Subscripts are these little guys, okay? The 2 here, the 5 on oxygen. Those subscripts refer to the number of atoms. So I have 2 nitrogens and I have 5 oxygens. That's what subscripts are, and that's why we'll use prefixes here. Okay. I want you to notice something. I want you to turn your periodic table on its back. You're going to see that there are prefixes there, 1 through 10, the same ones that are listed right here. Okay? Yes, you can use your periodic table during the test, during a quiz. So you do not have to memorize these prefixes. You will have them with you at all times. Okay, so let's look at this compound here. We have N2O5. Let's go through our rules here. Rule number 1, write the full name of the first atom. My first atom is nitrogen. Check. Rule number 2, write the name of the second element, but change the ending to IDE. Okay, I have a little bit of flexibility here with you trying to change endings to IDE. You'll start to see a pattern and you'll recognize them. Also on page 2, there's some common IDE endings. So oxygen is actually going to change to oxide. So here we have nitrogen oxide, and you've probably heard that oxide before. Okay, so we've done number 2. Let's go to number 3. Use Greek prefixes to identify subscripts, numbers of atoms. All right, we'll start with nitrogen. There's a 2 spot there. So we go to our prefix chart. 2 is di. So we're going to say dinitrogen. And then we go to our oxygen, and there's a 5 there. So we have to find 5. Penta. Now we don't want to put 2 vowels in a row and say pentaoxide. Instead, we'll just make it smoother and say pentoxide. And once again, there's some flexibility there. As long as you get the right idea, you have the right prefix, you'll be good. Okay, so we have dinitrogen pentoxide. That's how you would name that. Okay, so I'll pause it here, and you can try and name these compounds. The 2 compounds up here, name those, and then look at the 2 that are named. This says chlorine dioxide, if you can't read that, and then dichlorine monoxide. Pause it here and fill those out. All right, so here are your answers. We have 4 phosphoruses, so we have tetra phosphorus. Name out the whole atom. Phosphorus, yeah, there we go. Tetraphosphorus, and then we have 10 oxygens, so that's decoxide. All right, over here, 2 nitrogens, dinitrogen. 4 hydrogens, tetrahydride is what you do with hydrogen. Tetrahydride. Okay, chlorine dioxide. Cl, just 1. Dioxide means 2 oxygens. ClO2. Dichlorine monoxide. 2 chlorines. Mono means 1 oxide. Okay. This is going to take us to our last rule here, and it's just the exception. So let me pull up. No, we don't want that. Let's pull up another slide here. And that is for something you might have heard of, CO. Okay, so the name of CO is carbon. Oops, make that an R. Carbon monoxide. All right, we have 1 carbon, we have 1 oxygen. You're only going to use the prefix mono for the second element. If you just have 1 of whatever your first element is, you just leave it blank. So you don't put anything there. So here's your last note. Only use mono for second element. You could leave it blank if it's the first one. Okay, so that's how you do covalent naming. Happy to answer your questions. Just send them over to me. Right now, where you want to move to is to do page 3 in the packet, where you're going to go from the name to a formula, and then from the formula to a name. Hopefully, this is as easy for you as it is for me. I think that you guys will be successful doing this, so rock it out, and have a good day.